All right, equation of a line. I freaking love equations of lines. This is going to be a little wild video because this is like a huge unit in Algebra 1, and we're like, boom, in one lesson. So I'm going to do my best. I'm going to do a quick review here. We're going to talk about how to write the equation of a lines. I hope you enjoy it. Okay, so here's some quick review for somebody just walking in the door, right? So the coordinate plane is this arbitrary grid we place over everything, right? We can place it over a computer screen, all the pixels are X and Y. We can place it over a map, longitude and latitude. So we're just placing any arbitrary scale in there. The units could be inches, millimeters, pixels, right? It doesn't matter what you're counting, but you're counting how many over and how many up to create a grid, right? And even the origin's arbitrary. When I program video games, each character or game object has its own separate axis with its own separate little local universal grid, right? So once we place the grid, and we all agree on the 0, 0, boom, and the direction of the x, y. Now we've got a common language we can talk about. Points are locations in that space, right? They're an ordered pair. We always do the x first and the y second. So that looks like, if I say, oh, the point 3, 4, I'm always talking about x comma y. So from that arbitrary 0, 0 we all agreed on, we go over 3 x's. And up positive 4 y's, and we all agree that this is the point 3, 4. So that's what a point is, an ordered pair. X and Y intercepts, nothing special. They're just the easiest points to find because it just happens to be 0. 0 is such an easy number. And so all this is if I have a line, where does it cross the x-axis and where does it cross the y-axis? With a straight line, it crosses both axes at most once. If it's parallel to an axis, then it doesn't even have one intercept, it only has the other. But with a curved line, right, if you start talking about quadratics, cubics, I mean, you can have tons of intercepts where it's just so zig, 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 zig. But with straight lines, at most, it's got one x-intercept and at most one y-intercept, but it could have 0, as I said. It could be a horizontal line here that has a y-intercept of 3 and an x-intercept doesn't exist. Right? We always know the x-intercept because it's crossing the x-axis. We know the y value is 0. So the x-intercept they might give you as a single value. They might say, oh, the x-intercept is 3. But don't be fooled. That's not a separate single value. That's an ordered pair. The language x-intercept is saying that's a point 3, 0. If they say, oh, and we've got this y-intercept of 4, that's just another way to say I have the point 0, 4. Okay. All right, and then equation of a line. So what is it? Big picture. This is beautiful, right? So really the equation of a line, right? Let's just, let's say 2x plus 3y equals 5. Really that's a relationship between x and y. So now x and y aren't free roaming on their own. Now it's this restriction. So there isn't this degree of freedom where you can choose both an x value and choose a y. As soon as you create this relationship, this equation binding them together, what that means is you can choose one. But then the other is calculated. So really simple example, y equals 2 times x, right? If I choose x is 3, then its only partner y that goes on that line is if y is 2 times 3. Like we literally plug it in. We go y equals 2 times, we plug 3 in, and we get y has to be 6. Same thing, we could plug in a y value. We can go, oh, here's a 10. Well, then we plug it in. 10 equals 2 times x. We solve for x, it's 5. So you can only choose one variable and then we calculate the other, right? Each of these equations, like y equals 2x, has infinitely many solutions. Okay, I know I'm going fast. I'm reviewing everything from algebra you need to know about the coordinate plane and graphing lines, which is a lot of information. Right, so every equation of a line has infinitely many solutions. So let's take a really easy one. Okay, I know I already had an easy one over there, but let's say x plus y equals 5. Okay, well we got already. Let's think of a bunch of solutions to that. Well, we could have 2 plus 3 is 5. We could have 0 plus 5 is 5. We could have negative 2 plus 7 is 5. We could have 4.5 plus 0.5 is 5. So we could think of infinitely many pairs. And each one of those pairs, 2, 3, is a solution. So down here I say a solution means if we plug this ordered pair, if we plug in the x for the x and the y for the y, I get 2 plus 3 equals 5. Check. That is true. That means the ordered pair, 2, 3 that I wrote up there, that means that is a solution to this equation. That means that point lies on this line. Whereas if I come up with a random other point, 6, 1, And I plug it in and I go, okay, well, is x plus y equal to 5? 6 plus 1 equals 5. I get 7 equals 5. That's not true. So 6, 1 is not a solution to this equation, meaning it doesn't lie on the line. So really the equation of a line represents all of the points that lie on the line. Every single one of those you plug in and it works. Every other point in space you plug in, it doesn't work. Okay? And so if I were to say like, oh, well, tell me all the solutions to this equation, you'd be like, I don't know. You'd start a list. You'd be like, well, 5, 0, 4, 1. And I'd be like, well, what about in between? You'd be like, okay. 4.9 and 0.1. I'd be like, even in between those, you'd be like, okay. 4.99 and 0.001 and like it would keep going forever. There's no way to infinitely list all the points, but instead, like, look at the magic of it. Literally on this coordinate plane, if I want to list them all, well, I just go, oh, well, there's this point 50, right? I know that one. And there's this point 41 and 32 and 23. Oh, and there were 2.5, and oh, and 4.9.1. And as you graph them all, you graph every single one, what you end up getting is the dots are so close together that what does it look like, right? I mean, not what does it look like, what is it, right? Infinitely many points, so close together, all of those points make a line. And all a line is, it's not a separate thing. It's literally the collection of points infinitely close together with no gap in them that visually shows you, here are the infinitely many solutions. I don't need a list of comma, here are all the points. I just show you a picture, right? A picture's worth 1,000 points. Here's a graph is worth infinitely many points. So I mean, that's a beautiful thing right there. So that's what the equation of a line really represents. Okay, now, if you have no idea how to graph something, right? You're on a test, you get math anxiety, you just blank out, and it's like, teacher says, graph this thing. Well, you always have a backup plan, right? Here's an x squared. Like, you don't even know. I don't remember quadratics. Who knows? I can always graph something. All you do is go, well, I make a t-chart. I remember that crazy Mr. Dilloughery. He said I could come up with any number I wanted. Let's come up with, like, 0. That's an easy number. What's the next easiest number? 1. Well, let's also check out negatives. And then let's do another one. The next easiest is 2. Let's also plug in -2. And so all you do is make up values for one of the variables. Doesn't matter whether it's y or x. Okay, usually we choose x, but maybe in some situations you choose the y's. And then we just plug them in and see what we get. Okay, well, let's plug in 0. Well, that's easy. We get -1, right? 0 squared minus 1 is -1. Okay, then we do the same thing for 1. 1 squared minus 1, that's 1 minus 1 is 0. 2 squared, that's 4 minus 1, that's 3. And then we do the same thing on the other side. We go, okay, -1 squared. So -1 in parentheses, because we're replacing the variable. So the whole -1 is squared minus 1. So that's 1 minus 1 is 0. Oh, look at that, some repeat. And then we go -2, again in parentheses squared, because -2 is the x times x. Minus 1, so that's 4 minus 1, that's 3. Oh, look at that. And then we just go over here and we graph those. We go, oh, -1, 0. And we go 0, -1, and 1, 0, and 2, 3, and -2, 3. And oh, look at this. Kind of looks, and you just kind of sketch it and graph it. I don't know. It's probably something like that. Or maybe you connect them with straight lines, and you're like, I don't know. It looks something like this. It's a sketch. And the more points you come up with at the t-chart, the more accurate your graph is. But that's always a backup plan. If it says graph and you have an equation, just plug numbers in and you got it. All right, let's start today's lesson. Okay, the equation of a line, slope-intercept form. Why'd they name it slope-intercept? Because literally as you read it from left to right, you go, that's the slope, that's the intercept, right? Y equals mx plus b. The m stands for slope. I've looked up why. It's a crazy reason. It's like the first book published in like, I don't know what year a French person wrote. There's maybe a word from French that starts with an M. Doesn't matter. We have m for slope. B stands for y-intercept. Okay, so here's an example, right? We have y equals 3x plus 5. So we just go by the coefficients here, right? The coefficient next to x is the slope. And the thing without a variable, just the other term there, that's just an integer, that's the y-intercept. Right, and I did it off the side. So the slope is 3, y-intercept is 5. The next one, easy peasy. The slope's -2. Y-intercept is, oh my gosh, so look at the next equation. Y equals 5x. Mr. Drew, you told me it would work. What's going on? Okay, well, here's what's going on. Could we write 5x plus b? Like, could we write this in that term? Well, sure we can. Look at this. A little ghosted plus 0. So what are we adding to 5x? We're adding the number 0. So that's totally okay. We just put a y-intercept as 0. So if we were to graph this, we go, where does it cross the y-axis? It crosses at 0. That's the origin. And then we go, oh, what's the slope? The slope's 5. So we go up 5 over 1. Oh, there's my graph. I do it a few more times. 5, 1, 5, 1. I go, oh, there's my line. Boom, graphed it. Okay, what about 7? Oh my gosh, it's crazy. But no, it's not. It's not crazy. Because how many x's do we have? What's the coefficient of x? We got a ghosted 0x. And then plus 7. Plus 7's okay. And so the slope there is 0. Well, what's 0 as a slope? Oh, y-intercept here. That's definitely 7. So if we wanted to do a little graph of that one, we just start up here at 7 and go, okay, which direction do we go? What's a slope at 0? Again, we just turn any slope into a fraction. So 0 is 0 over 1. So that means go up 0, right 1, up 0, right 1, up 0, right 1. Oh, yeah, that's the horizontal line because the slope is 0, meaning as we move left to right, we are adding 0. So the y value is not changing. So we're just staying the same. Got it, got it, got it. So every single equation, a linear equation, straight line, can be written in this form, except, right, that one stinking loophole. You divide by 0, right? You can't divide by 0. So every linear equation can be written this way. And you can find the slope and the y-intercept. Easy peasy. Every straight line on 2 dimensions can be written this way, except a vertical line. Here's the reason, right? If you want to get it in y equals mx plus b, all you got to do is solve for y. Once you have positive 1 y equals, then all you have on the other side are x's and numbers. That's a linear equation. You have x's, y's, and numbers. So all you do is shove everything to the right, divide by the coefficient of y, so you have positive 1y here on the left. As long as you just get that y equals, there's the equation, right? Even if it was y equals 0, that's okay. That's the same as 0x plus 0. So slope is 0, y-intercept is 0. That's great, right? So that's just at a coordinate plane. Here's the y-intercept. Up 0, right 1, up 0. And so it's just a horizontal line. That's the equation of the x-axis itself, right? No problem. The problem is we can't solve for y if there is no y, right? If this is the equation of the line, how do you solve for y? There isn't even a y. Y doesn't exist, right? So x equals 3 is that one loophole. That's a vertical line. A way I think about this is make a t-chart. You go, I'm bad with dichotomies. I forget. Is this the horizontal? Is this the vertical? I get them switched up. Don't do that. Let's have a safety net here. Say, okay, well, let's see. My rule is x has to be 3. That's a really easy rule. Y can be anything we want. 1, 2, 3, 4. Our rule is that x is 3. Got it. All of these points are solutions to that. And then go ahead and graph it. Like, what does that look like? Over 3 up 1, over 3 up 2, over 3 up 3, over 3 up 4. Oh, that's a vertical line. Got it. And the slope there is undefined. So if we were to write it, we'd be like, okay, well, the slope is undefined. And then that'd be times x plus, and then there'd be like no y-intercept exists. Like that's like, how do you write that in y equals mx plus b? The slope is undefined, and there isn't even a y-intercept. So the only one exception to y equals mx plus b is that vertical line. And that's a separate thing that you just know is always x equals number. Period. That's it. That's the only exception. Okay, so let's come up with a strategy. How do we write it in y equals mx plus b? What if they throw us a curveball? That's okay. All right, so here's what we do. First thing, you find the slope, okay? So for example, green here, I got a problem, okay? Find the equation of the line passing through these 2 points. Okay, step 1, let's always find the slope. So we just plug in the slope formula, right? So let's see, here's an xy, and here's an xy. We'll call this point 1, and this point 2. So we just go 9 minus 1 over 4 minus 2. Okay, so the slope is 8 over 2, so the slope is 4. Okay, step 2, find a point on the line. Got it. It doesn't matter which point, right? Done. Okay, so you found a point. Point is 2, 1. Right? Or you could have used 4, 9. You get the same equation either way. Otherwise, math's broken, right? So it should work out no matter what point on the line you get. If you use the correct slope at any point, you will get the same equation on the line. Right? So then plug in point and slope into y equals mx plus b. So let's see what we got here. So we got y equals mx plus b. Well, I just said we had a slope, right? So let's plug in the slope. The slope's 4. And then we had a point, right? 2, 1. So let's plug that in. So the y, right? This is xy. So the y is 1, and the x here is 2. And then let's see what we have left over in this equation. We have equals plus b. Oh, okay, so this is 1 equals 8 plus b. So we can just solve for b, right? So we subtract 8, subtract 8. So b has to be -7. And really, like theoretically, big picture, what's happening here is for this point 2, 1 to be on the line, which we know it is, but it said so in the question. For that point to be on the line, we have to find the exact 1 b value so that that point works out to be a solution. That's what's going on here. There's only 1 b value that shifts the line up or down the y-axis until it's aimed right through that point, right? So that's what we're doing. We go, oh, b -7, that's the y-intercept that shoots that slope through that point. And then finally, we just write the equation. We go, we know b is -7, so we have y equals mx plus b. So now all we do is put in the slope, right? We have the slope up here was 4. So we go y equals 4x, and then y-intercept -7. So you write plus -7 or just -7, doesn't matter which one. There we go, right? And notice I said leave the x and y as variables. So it's a little confusing, right? Here you plug in the x and y to use them to solve for b, right? You plug in a point. However, in your answer, remember that the equation of a line is a relationship between x and y. It needs to have those variables in there for you to be able to plug in numbers and use it, for it to represent infinitely many solutions. There still has to be those variables, or at least one variable. Okay? All right, so here we go. How do you find the slope, though? Because I just said in step 1, just find the slope. But you're like, that's a big ask. I mean, come on, Mr. Okay, so here's how you do it, right? Either it's given to you, right? Some questions, they're like, m equals -4, ... and you're like, done, found it, right? Or it could be given to you, right? Like sometimes they're like, find the equation of this line, and they'll give you a couple points, like here's a point, and you go, oh, I'll just count, right? So you count from a graph. Or it could be hidden in information. Like we just saw, if you're given 2 points, that's a way of hiding the slope. And you go, haha, I found it. You just use the slope formula. Or graph it and count, right? But okay, we just did that. Or it could say, oh, write the equation of this line that's parallel to this other line. The parallel to the other line is telling you the direction of your line, right? So you rearrange that first line into y equals mx plus b, and then you just take its slope and say, well, mine's parallel, so it has that same slope. Got it. Found the slope. Or similarly, it could say, oh, it's perpendicular to this other line. Again, find the slope of that first one, right? Write it in y equals mx plus b and go, I found the slope of that other line. And so my slope is you flip it over and change the positive negative, right, to get that perpendicular slope. So either way, you can find, hidden by one of these reasons, right, you can find the slope, or it's just given to you in a picture or written, right? But that's how you find the slope. Okay, so let's do it, right? If it says write the equation of slope-intercept, remember slope-intercept, that's y equals slope plus intercept. It's really easy to remember. Okay, so we're just going to write it. So y equals, I know the m, x plus, I know the b, so I just put it in. So the m is 1/6, the b is -4, done, equation of line. Oh, but over here, they don't give me the slope. I mean, they give me a point, but they don't even give me the y-intercept. Gosh darn. Okay, so let's do it. All right, so first things first, we go the slope is equal to, I'm going to call this my first point, this is my second point, so 1, 1, 2, 2. And so I'm going to go, this is -6 in parentheses minus -3. I got a lot of negatives. And then 10 minus in parentheses -5. So the slope here is -6 plus 3 over 10 plus 5. Or in other words, -3 over 15. Or in other words, the slope here is -1/5. Okay, and then we're going to just plug it in. We go, okay, well, half my answer is y equals -1/5 x. Plus something. So I already got most of my equation. All I need to do is figure out that b. And so what I do is I plug in my x and y, right? Doesn't matter which one we use. Sure, let's use the one I circled already. So we go -6 equals, and I'll plug in my 10 here for x. Okay, and the rest will stay blue. I already have the -1/5, and now the plus b. I got to solve for that plus b. So here's -6 equals, I multiply these, and I get -2 plus b. Add 2 to both sides. Okay, so b must be -4. Sadly, a lot of people stop here. You never wrote the equation of a line. Yeah, you did all the work, but you never explained or demonstrated or communicated the answer. The answer is bring the m and the b together and actually write the answer. Y equals -1/5 x plus -4 or -4. That's the answer there. Boom. Okay, let's do another one. This time, write the equation of the line that passes through a point and is what? Parallel to? what is this hidden magic, right? So first thing we do is we go know it's parallel to this. Let's rearrange this in y equals mx plus b so we have the slope of this line. Okay, so let's do that. So let's move the x's to the other side. Okay, so we got negative 5y equals negative 2x plus 8. Okay, and then we'll just divide everything by negative 5. And so we get y equals negative 2 over negative 5, which of course that's positive, but I'll leave it for now. Minus 8/5. Now that looks scary, but we don't even care about the y-intercept here. All we care about this slope. So the m equals 2/5, right? Negative divided by negative is positive. And ours is parallel. So if ours is parallel, then we know our slope is 2/5. Got it. Okay. And then do we have a point? Oh, look at this. We got a point. 7, negative 2. And now it's the exact same as the other problem that we just did here. Okay, so we're just going to go y equals 2/5 x plus b, and go, shoot, what is the b there? We got to figure it out. And oh, dang, it's going to be some fractions. That's okay. We're not scared. So we plug in for 7 here, and that's for the x. And then, so we're just plugging in the point into this equation, and we're leaving the slope, and we're leaving the b. Okay, let's do it. So we got negative 2 equals 14. So I just do over 1, top times top, bottom times bottom, fifths plus b. Subtract the 14 fifths from both sides and go, oh shoot, how many fifths is this? I don't know. And so let's just rewrite this. So this is negative 10 fifths minus that. And so then b is equal to, and you combine those, you get negative 24 fifths. And so then we just write the equation. So the final equation is slope-intercept y equals 2/5 x minus 24 fifths. Done. Fireworks. Okay. Now, we can actually more elegantly, more quickly jump to the equation of a line. We actually don't need to do all this work. That's extra. We don't need it. There is a more direct avenue. Once you have a point, or I mean a slope and a point, we could use, look at this, point-slope form. So if you have a point and a slope, you could just write the equation line right away. And so here it is. It's y minus y1 equals m times x minus x1. Now you might say that's a lot of variables. You're asking a lot of me. It's actually straightforward. It's a formula you literally just plug a point and a slope into and you're done. So you leave the x and the y. Those stay variables. But the three things I underlined here, right? The y1, the m, and the x1 become numbers. So I'll do an example right below, okay? So if I tell you that the slope is 3 and the point is 2, 5, you literally just plug in the slope is 3 here. X, whoops, that's x, and then y, you literally just plug those three numbers in, boom, you've got the equation in your line, okay? So here's my equation, right? I put the y, I put the slope, I put the x, done. Equation in line, done. All I did was find a slope, find a point, put them in, done. Equation in line. Now, if you wanted, you could rearrange that for sure. You just distribute in the 3, and you get down here at the bottom, y minus 5 equals 3x minus 6. Add 5 to both sides. Oh, boom. We rearrange it to y equals mx plus b. No problem. We can do that. But you can go directly from a point and a slope into the equation. That is a great doorway, a shortcut right to it. So that's really useful. And just again to highlight, it's a more direct approach, but you can just use y equals mx plus b for every problem ever as your bread and butter, unless your cruel, evil math teacher says, write this one in point slope form. And then you go, oh snap, I had one method and he wants me to be flexible and adapt to new situations. So I get it. So again, you could do that same problem just with the y equals mx plus b, which I did here. I said, well, I know the slope is 3. I plug in the point into the equation with the slope. We solve for b. We get b is negative 1. And then you just plug it in. We got the same thing, right? We got the same thing as up here. It's just you don't need to do that work. You can right away have the equation of the line, which again, nice shortcut. Okay, now before we go into just a bunch of homework problems, why? Where does point slope magic come from, okay? So here's the big idea. We used to use the slope formula just by plugging in 2 points and getting the slope, right? So we didn't know the slope, but we knew all the rest, right? We plugged in point 1, we plugged in point 2. These all were numbers. We put it into the sausage grinder. Out comes number, right? And we go, oh, we got the slope. That was an easy, useful formula. Well, we could use that formula in a clever way by instead of saying, I know 2 points, give me the slope, I could instead say, I know a point and the slope. Let's plug it in and look what's left over, right? The thing we don't have so far now is a point. So up here, we plug in 4 numbers, out comes a single answer. There's one solution to this. We find the one slope, right? But if instead we don't know an x and a y, but we plug in the slope, we plug in 1 point, think about that. Conceptually, we're saying we have a point and a direction. What's the other point? Well, there's infinitely many points on that line, right? You start at any point and go in any direction. That's a line with infinitely many points. So there's infinitely many solutions here. Another way to say it is one equation with 2 variables, infinitely many solutions. So find an unknown point on a line. There's infinitely many things. So it's literally just this equation that is the equation of a line. Isn't that cool? So here's an example, right? Here's a slope 5 and a point 1, 2. And I'm saying there's some other point x, y on the line, which there's really infinitely many. But okay, so we plug in the slope of 5 and the point 1, 2. And then we leave this x and y because that's our unknown other point that there's infinitely many of. Okay? And then we go, well, could we rearrange this? We're scared of fractions, so let's just multiply both sides by the quantity x minus 1, right, in parentheses, and look at what we get. We get y minus 2 equals 5 times x minus 1. That's exactly point slope form. Right? Look up here. That is point slope form. We plugged in the slope, we got the points, and it's exactly that. So that's all it is. We literally just took the formula m equals y2 minus y1 over x2 minus x1, and we multiplied by this on both sides. And so what happens is that thing just moves up here. That's all we did. We just went, and then we used the formula. Instead of saying, I know 2 points, give me slope, we said, I know a point and a slope. Give me equation of line, or give me, more specifically, another point on the line. And that's it. Oh my gosh, just beautiful. Okay, let's just do a bunch of problems now. So write the equation of the line with x-intercept. Oh, what the heck is an x-intercept? Remember, an x-intercept is where we cross the x-axis. So what we know is the y value is always 0. So really, this is telling us we have a point. Oh, you decoded, secretive. It's just a point. Look at all those fancy words. Okay, perpendicular to, oh, it's so scary. But what we're going to do is we're just going to calmly rearrange this. We're going to, okay, well, I'm not going to work in blue. That's crazy. Let's work in green. Okay, so we're going to subtract the 3x from both sides. We get negative 5y equals negative 3x plus 6. We divide by the negative 5. We get y equals 3/5 x minus 6/5, okay? So the slope of this original line is 3/5, okay? But it said our line is perpendicular to that. So our slope is the perpendicular to that. So in other words, we flip it over, 5/3, and we switch the sign. This was positive, so our new slope is negative. Okay, first things first, we found our slope. We have a point, negative 8, 0. We could do the y equals mx plus b, or we could just be done, right? We just go, here's my xy, here's my m. Remember my equation, y minus y1 equals m times x minus x1. And so the equation of our line is literally y minus the y1 equals slope times x minus x1. So x minus negative 8. Right? So we could leave it like that, or you could simplify it a little bit and say y equals negative 5/3 x plus 8. Boom, done, right? That's so easy. And it just said write the equation. It didn't say which. So this would be point slope, or this would be point slope, or you could write it in slope-intercept just by distributing that in and going y equals negative 5/3 x plus, and then we just multiply the 8 in and we get negative 40/3, right? And so any form you want. We got point slope, we got y equals mx plus b. All right, so just to review this chapter, really, this entire chapter just says we got 4 biconditionals. If parallel lines, then corresponding angles. If corresponding angles, then parallel lines, right? All those biconditionals, there's 4 of them. And then, and y equals mx plus b. But embedded in y equals mx plus b is so much. What is a line? What is a solution to a line? Write the equation of a line. Graph this equation of a line. What's the slope of that line? There's so much there. But that's the big idea, right? Equation of a line in coordinate 2D space. That's it. Okay. And I did this just in case you wanted a little flow chart. It's a tiny bit blurry because I just took a picture of some old notes. But this is a nice way to just say, how do you find the equation of a line? Pause it there. Got it. Okay, here we go. I'm just going to do a bunch of homework now. How would you write the equation of a line whose slope is this and that contains this point? I would literally just plug it into point slope form, and I would go y minus 8 equals negative 2/5 x minus negative 2, which is x plus 2, right? Because this was x minus negative 2 there. Right? Boom, done. Literally write it in, no work to do. So, and then you would explain that. But I would plug the point and the slope into the point slope form. Done. Okay, write the equations in slope-intercept form for two lines that contain that point. Whew, slope-intercept form though, so we gotta do y equals mx plus b. How could we know though that our y equals mx plus b goes to this point? Well, we could do a couple things. Like one, we could go, well, we know this point, we don't know the slope, okay, so m, and we do know this point, negative 1, plus b. Okay, so we know that that point has to be on the line. So we could just literally come up with m's and b's that satisfy that. So let's just say, well, what if the slope of this line was 1 and it went through that point? Okay, so let's just plug in 1 here. Okay, so we know the slope is 1. Well, then what would b have to be? We don't have freedom there. We would have to solve it and say, what's the only y-intercept, right? If I start at that point and have a slope of 1, it's already aimed. It's already determined. It's going to hit the y-intercept somewhere. So let's solve for it. Negative 5 equals negative 1 plus b. We add 1, we add 1, we get b equals negative 4. So we got y equals x minus 4, right? So that's 1x, and then plus negative 4, just minus 4. So that's one way. Or we could go directly to point slope, right? I could say, well, point slope is y minus negative 5 equals some slope times x minus negative 1, right? And now we just do any slope we want, okay? So let's do a slope of 2 this time. All right, so here's a slope of 2, and so we get y plus 5 equals 2 times x plus 1. Although it said put it in slope-intercept. This is point slope, right? Slope-intercept goes y equals slope x plus intercept. Like in order, it does slope then intercept. And so here we could just rearrange this. So distribute y plus 5 equals 2x plus 2 minus the 5, and we get y equals 2x minus 3. Okay? Or we could think of a really easy 2. What are two easy ones? We don't even need a diagonal line. What if we just did a horizontal line? Ready? Y equals 0 x's plus, what's the y value that we're keeping the same? Negative 5, right? So you could literally write y equals negative 5. Or, if you want to say the vertical line, you just go x equals whatever the x value is of all the points on the line, negative 1. Oh my goodness. So there's 4 different approaches to writing the equation of a line through that point. Okay, so write an equation in slope-intercept form of the line given this. Okay, so we could just write, and this says slope-intercept, y equals mx plus b, so y equals 1/2 x plus 4. Oh, that was nice. Okay, and then this just says an intercept at this. Well, which intercept is that? 0, negative 2, this point. Oh, that's the intercept of the y, so it's the y-intercept. So y equals negative 3/5 x minus 2. Now, if it had been negative 2, 0, we would have had to do some solving. We would have said, oh, that's an x-intercept. We need to follow this slope and see where it crosses. And so that would have been a different question. But they gave us the y-intercept. That was so nice of them. Okay, write the equation in point slope form of the, oh, well, it gives us a point and a slope and a point and a slope. So we just write it, right? So here's good practice. So y minus the y value equals slope times x minus the x value. So just to get rid of that extra parentheses, y plus 1 equals 3/2 x minus 4. Okay, this one over here, y minus 5 equals 3x minus 7. No extra parentheses to get rid of. Easy peasy. Okay, refer to the figure right, write the equation. Okay, so we're given a picture. Let's write the equation of L. Okay, well, they only give us 2 dots. So let's use the 2 dots they give us because we don't have any others, okay? Well, first of all, for 10, we're given the y-intercept, right? The y-intercept I can visually see. It's labeled. It crosses the y-axis at 5. And then we need to find the slope. Well, the slope is up to right one. I'm going to work in pink on this drawing here so it stands out a little bit more. So we're going to go up +2. We're going to go right +1. So the slope, whoa, that's a 1. The slope here is positive up to right 1. Okay, I should write +2 over +1. Or just 2. And so if we want to write the equation in line, let's check the format. It's slope-intercept. So y equals, whoops, I wrote it backwards. Slope of 2x plus 5 is y-intercept. Okay, so 11. K, again, they give us the y-intercept. And then the slope is just, I'm going to do it somewhere else. I'm really doing it between these, but it's just too small. But really, it's down -1, right, +1. Okay, it looks a little off there, but they do give us these 2 points. That's weird that it went off. That's a book error. They did show us those 2 points just to erase it and clean it up. Okay, they did show us that it went through those 2 points. They just did a bad job of visually graphing it. So we know our slope is -1 over +1, or -1. And our y-intercept, or b, is 2. It passes through 2. So the equation of our line is y equals -1x plus 2. And I'm going to put an asterisk right there because there's some error they did. It should be right through those diagonals and right through these diagonals. Tisk, tisk, tisk. Okay, let's look at 12. The line parallel to L. Oh, so it's got the same slope as L. Well, we know the slope of L. We already did it. Slope of L is 2. Oh, well, that's nice. Y equals 2x. But it says that contains 4, 4. Ooh, that's good. We got to think, how do we get that? Well, let's say we don't know the y-intercept, but we do know it passes through 4, 4. So we can just plug in the 0.44 and solve. Okay, so let's plug in the 0.44 and see what the y-intercept has to be. If it has a slope of 2 and it passes through that point, then we go 4 equals 8 plus b. We subtract the 8. We get b equals -4. Oh, there we go. It's y equals 2x minus 4. Woohoo! Okay, now we got this internet problem. Let's see what this says, okay? Justin's current internet service provider charges a flat rate of this much per month for unlimited access. That's a pretty good deal. Unless it's like really slow internet, then I guess that's not a good deal. You're just giving them money for nothing. Okay, then another provider charges this much per month. Ooh, that's a deal. Oh, but this much extra for each hour of connection. Okay, so first write an equation to represent this. Okay, so first off, the equation for the first one, right? For each plan. Okay, so I don't know. There's no. Oh, let's just call it current. Okay, so for current, this one's really easy. The first one, what do you add? Every per hour, per data, per anything, you add 0. So the slope here is 0x plus the y-intercept, the starting cost that they give you is 39.95. Or you could just write y equals 39.95 because it never changes, right? It stays 39. Like they even called it a flat rate because it's flat. It never goes up or down at all. So that was an easy one. Okay, but another, this is a good name, current and another. Now they say we're going to do this $4.95 per month. So if we, on a graph, if we label this by month, okay, and this is by dollar, and that's our scale, well then the rise over run is price per month. So that is, the slope is $4.95, okay, per month. Oh, no. I'm going to step that back. We all make mistakes. I should have read further. For access, so that's per month. So we're talking about that's a monthly bill, but that's not our graph. Our graph is, we're trying to say how many hours each month. So really this graph is, each month we create a separate graph, and this is by hours. So this is how much does it cost per hours, and then each month will have its own one, okay? And then each month you will say, well, on this graph, what was my cost? Well, my cost was this month I used 10 hours, so here is my cost this month. And the next month you would say, okay, So we'll have the same graph each month. What it is that each month we'll have a different point on the line. Oh, I landed here this month. Oh, I landed here this month. Okay, so let's redo that. Oh, that's cool. Okay, so back to blue. So we have, and we'll erase this. Okay, so the slope is we have an extra $0.95 per hour. Okay, and then we have a starting price, right? This is the $4.95 per month that's starting. So even if you never use your internet, you're on vacation in another country, your house is empty, it's overrun by spiders and snakes, and who knows what happens while you're gone, right? So you've got $4.95 is the starting price. You can't get less than that unless you can figure out how to use negative hours. Okay, so here we go. Now we've got y equals, whoa, I did it again. Okay, 0.95x plus 4.95. So starting value plus how much more per hour you're being charged. Okay, so we got our two equations. All right, and then the question is, if Justin is online an average of 60 hours per month, should he keep his current plan or change? Okay, so which one's going to cost more with 60 hours? Well, let's plug in 60 for the first one. So x equals 60. Oh, well, that was easy because we multiply 60 by 0. So the cost with the first plan is $39.95. Woohoo! Okay, let's do the second one, though. The second one is y equals, and we plug in this x of 60, but this one we have to actually calculate, right? Because for each hour, he's charged this much. So this time we get y equals, we got to figure this out with a calculator, plus 4.95. Now I know ballpark, I'm just going to estimate this. This is going to be around, I don't know, like 57 or something, right? Because it's 95% of it. It's almost 1 times x. So 1 times 60 would be 60. So a little less, let's say 57. So if we do 57 plus 5, we're around $60, period. We are much more than 40. So without even doing calculations, we know this is the better deal. I mean, unless what you were aiming for is to pay as much money as possible, then you can go ahead and do that. Okay, so I'm going to switch over to my calculator here. Here we go, and we've got clear. We got 0.95 times 60, and that comes out to, oh my gosh, are you kidding me? Exactly 57. Oh, that was good. Okay, so we add that up, and we get that the y cost for this one was 61.95. Oh, I should have known, right? 10% of 60 is 6, and so 5% is half of that is 3. That's silly. I could have done that in my head. All right, so let's do some more, right? So that's real world. So we're going to do one more like this, and then we're going to jump to last business ones, okay? So I guess 3 more like that. All right, last problems. Write an equation in slope-intercept form. So y equals mx plus b, given this, and just different stuff, okay? So one more practice with just points. Oh wait, we did this problem up above, okay? And then let's see, the x-intercept and y-intercept. That's not enough information. It's a panic. It's just the same. It's just 2 points, right? So remember, x-intercept, the y value is 0. So this is something comma 0. And then the opposite for y. For a y one, you want to know the y value, but you know the x is 0. You're saying what is the y, right? So over here, this is an x of 5, y of 0. This is a x of 0, and you know the y is negative 1. So the slope is negative. Actually, let's not even do that. Let's just count, right? Here's a graph. And they tell us on the x-axis it's 5. On the y-axis it's negative 1. And so we went up 1, right 5, both of those positive. So the slope here, left to right, is uphill. The slope is positive 1 over positive 5, or 1/5. Okay, and then we know the y-intercept. The y-intercept's negative 1, so that's just y equals 1/5 x minus 1. Well, that's easy. So, right, being able to adapt to different situations and not being rigidly stuck in one algorithm that tells you step by step how to do it, you just feel more comfortable. You can fall back on logic if you forget a formula on a test. Okay, so last problem like this, and we'll jump into a word problem. So what's the equation line perpendicular to that and contains that? Well, I know that we could divide this. So watch this. I mean, we'll do this in a couple different ways. If we divide this all by 2, let's just stick with me here. So that's y plus 1, because we have to divide everything on this side by 2, equals, and then this is just one term. So go back to your algebra 1, but this will end up being negative 7/8. x minus 7. And I know this is point slope form. So I know the slope here is negative 7/8. And the point is positive 7, negative 1. Oh, snap. So I know the slope and the y-intercept. Let's say, oh, you didn't know that. Oh, that's crazy. That's too hard. Mr. Dilloughery with your crazy shortcuts. But that's elegant, right? All we needed was the 1y here and the 1x, and it's in point slope form. Okay, so let's rearrange it to y equals mx plus b. So we got 2y plus 2 equals, we distribute, negative 7/4 x plus 49/4. Okay, we'll move those numbers over the other side. So we got 2y equals negative 7/4 x plus 49/4 minus 2. Now we're actually not going to care about this because all we really care about is the slope. But let's do it anyways. Okay, so minus 2 is 8/4. So this is 2y equals negative 7/4 x plus, and so we had 49, we took 8 away, so now we're at 41/4. Okay, then we divide everything by 2. So this is now y equals negative 7/8 x plus, and then this is 41/8. And you might say, well, how do you divide that? So really quick, if you have 7/4 and you divide by 2, that's the same thing as going, well, that's 2 over 1. And division with fractions is 7/4 times 1/2. And then we just do top times top, bottom times bottom. So that's why I knew dividing by 2 is the same as multiplying the bottom by 2. Okay, so we got our slope. Our slope of this line was negative 7/8. But our line is perpendicular to. So our perpendicular slope, right? And I'm just bringing this up here. Our perpendicular slope is flip that over and change the negative is positive 8/7. Right? And then it says write the equation line. It doesn't tell me the format, and it gives me a point, and I have the slope. So I'm going point slope formula, right? So y minus negative 3 equals slope times, and then x minus negative 2. Boom, done. I'm going to clean up those extra parentheses. So we get y plus 3 equals 8/7 times x plus 2. Done. And then you could rearrange it if you wanted to get it to y equals mx plus b. Okay, let's do one more conceptual word problem here. So use the following information. So the Rainbow Paint Company, I'm liking this company, sells an average of 750 gallons each day. So I'm already visualizing maybe the graph that's happening is day and paint sold or paint gallons sold. And so I'm thinking the slope is 750. Okay, that's what I'm thinking already. Go up 750 gallons over one day. Maybe that'll happen. How many gallons of paint will they sell in X days? Oh, well, each day, so after one, right? You literally go 750 sold in 2 days. That's 2 times 750. So in general, 750 times X number of days. Okay, that's good, okay. And then the store has that many gallons of paint in stock. Write an equation in slope-intercept form that describes how many gallons of paint will be on hand after X days if no new stock is added. Well, it's saying they started with this value. Starting with values are y-intercepts. So on here in paint gallons, they're saying we start at 10,500. And we're not ordering any new, and they sell this much every day. So every day they're going down, 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 until they crash through the floor. So the idea here is, instead of 750, they're saying that's how many they'll sell in X days. So we're taking that away from how many they have. So we're saying every day we lose 750. And we started with 10,800. I'm not putting the comma in here because now it's in an equation. You could if you wanted. It's a little faux pas maybe. Okay, and then let's go 48. Draw a graph that represents the number of gallons of paint on hand at any given time. Oh, that's just saying graph that. So let's do graph here. Okay, we can do any units we want. So I'm going to go, these are days. Okay, days. And then vertically, let's do, I don't know, thousands. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's my graph. So here's 1,000 gallons paint. Okay, that's the y-axis. And so we got 1, 2. And so here's our first point at 10,800. And then after that first day, they're now more at around 10,000. Then after 2 days, they're a little more over like this. And then you just keep going and going and going and just And it keeps going. Oh my gosh, they're running out of paint. It's crazy. And so if it takes 4 days to receive a shipment of paint from the manufacturer after it is ordered, when should the store manager order more paint so the store does not run out? So what we're going to have to do is figure out when does it hit this, and then we're just going to minus 4 days, right? Or maybe, who knows, 5 days. Maybe have a 1-day buffer. Maybe there's some traffic or a snowstorm, right? So maybe we plan a little bit ahead. Who's running this paint store? Okay, so here's what we need to do. We have the equation of the line, right? So the equation is y equals negative 750x plus 1080. Okay, and now the question is, when will this be equal to a y? Like, if we're looking at this point, we don't know what the x is, but we know the y is 0. So really, we're looking for the x-intercept of this. So all we do is plug that in. We go, well, we know the y is going to come out to be 0. And so we're just saying, when does that happen, right? So we're just saying, I'm choosing the value of y. Now let me plug it in and calculate the value of x. So we got negative 750x plus 1080. Okay, so let's do it. So I'm going to move the 750 over, so we're positive 750x equals, 1080. And I keep saying 1080. There's an extra 0 there. So we divide both sides by 750. I still have my calculator out from that other problem. So that is 10800 divided by 750. That comes out to be 14.4. So after 14.4 days, they will run out. Okay, so I'm thinking at least we have to order at, so we minus 4. So we need to order at 10.4 days, but let's give them a little buffer. So we need to order at least at day 10 or earlier. Boom. Good video, you guys. I had a lot of fun doing this one. What a cool concept topic. All right, hope you guys enjoyed it. Hope you guys can graph lines, write equations of lines now. Adios.